we've looked at factoring polynomial functions. We looked at a cubic factoring pattern. We've looked at a quadratic type factoring pattern. And we've looked at factor by grouping. Now, the reason why we talk about this is so that maybe we could try to solve this equation here. And if I look at this, this has four terms. And remember, whenever we always want to solve an equation, we need to make sure one side equals 0. Whenever we're solving an equation, we need to make sure one side equals 0, which this does. So what I want to do is look at this. Because there's four terms, I'm going to think and hope that this is a grouping type of question. So I'm grouping those two terms together, Looks like the greatest common factor is x squared, and the greatest common factor there is 1. So I end up with x squared times x minus 1 plus 1 times, that's 3x, and then 3x minus 1 there. So because I have identical quantities, I have 3x minus 1, 3x minus 1, it looks like I have x squared plus 1 times 3x minus 1. So I'm going to set this equal to 0. And what I do is set each of these quantities equal to 0. X squared plus 1 equals 0. 3x minus 1. So I have 3x equals 1. So x is 1/3. I know this is a real value, so I know this is a solution. Because we're looking for real number solutions. Here, I subtract 1 from both sides. So I get x to be plus or minus 1I, because I'm taking the square root of a negative. That's not a real number, so this has one real solution. That's x equals 1/3. Let's get another example. So I'm looking here. Looks like it's a cubic, and it's a difference, so I know it's going to be like this pattern, a minus b times a squared plus ab plus b squared. So my what cube gets me x cubed is x, and what cube gets me 8's 2 cubed. So a is x, and b is 2. So I have x minus 2, and then I have x squared plus 2x plus 2 squared. So it's x minus 2, x squared plus 2x plus 4. So I set x minus 2 equal to 0. I get x to be 2. Now if I set x squared plus 2x plus 4 equal to 0, it's not factorable. And if I were to use the quadratic formula, a is 1, b is 2, and c is 4. So x equals negative 2 plus or minus 2 squared minus 4 times 1 times 4 over 2 times 1. So I have negative 2 plus or minus. If I look underneath there, it looks like it's a negative 12 over 2. That's not a real solution because I'm taking the square root of a negative. So whenever I factor out a cubic, there's going to tend to be only one solution, which is x equals 2. So let's look at this one. All right, so this is a quadratic like. So 1, how about negative 9 and negative 1? Okay, so let's look here. I know it's going to be 1x squared. I also know it's negative 3 and negative 3. And 1x squared. I'm going to go with minus 1 minus 9. So I get minus 9x squared minus 1x squared gets me that negative 10. So that works out. This can factor out to be x plus 3, x minus 3, and then x plus 1 x minus 1 because these are both the difference of two squares. And I get x to equal, looks like negative 3, positive 3, negative 1, and positive. So you have a couple examples to do. Try to do those, and we'll talk about those tomorrow.